Hello, everyone. Welcome to our class of numerical control again. As an old saying goes, a workman must first sharpen his tools, if he is to do his work well. We have seen what CNC processing is. So we still need a powerful tool to maximize the speed, efficiency, and precision of CNC machine tools. Next, I will introduce the commonly used cutters in CNC milling with you. Firstly, let's look through the common types. There are so many cutters. First, the cutting tools can be categorized into solid type, insert type, and special type tools in terms of the structure. Second, according to the material, it can be divided into high-speed steel tools, carbide tools, diamond tools, cubic boron nitride tools, ceramic tools, and so on. At present, high-speed steel tools are the most commonly used in CNC machine tools. Thirdly, classified by cutting process, there are drill bits used for drilling, including various center drills, reamers, deep hole drills, etc. Reamers are used for reaming, mainly including straight handle, conical handle, cylinder, cone, straight groove, spiral groove, and so on. Boring tools for boring machining mainly include those of single blade, double blade, floating, fine control, and so on. The main cutters used for threaded hole machining cover, taps, thread milling cutters, thread chases, and so on. There are also various milling tools used for milling contour grooves. Milling tools are the main application tools on CNC milling machines, including the cylinder milling cutter, end milling cutter, hard alloy face milling cutter, keyway cutter, side milling cutter, saw blade milling cutter, angle milling cutters, and ball end milling cutters, etc. Among them, end milling cutter is most commonly used in vertical CNC milling machine processing. According to the different number of teeth of end mills, they can be divided into three types: dense-toothed cutting tools, fine-toothed cutting tools, and coarse-toothed cutting tools. Among them, dense-toothed cutting tools typically have 10 to 20 teeth, mostly made into nestled structure due to its plentiful teeth and large size. Moreover, due to the small feed rate per tooth of the dense-toothed milling cutter, it is mainly used for machining thin-walled workpieces. Fine-toothed cutting tools generally have 5 to 8 teeth, and due to the large number of teeth, the cutting is smoother, so it's more commonly used for precision machining. Coarse-toothed cutting tools generally have 2 to 4 teeth, having a large chip space, so they are commonly used for rough milling of steel parts and castings with intermittent surfaces, mainly for rough machining. For the detailed structures and applications of the milling cutters above, I will introduce it in detail in the following classes. And here, I won't talk about it anymore, since we have known the types of the CNC milling cutters. And then, let's analyze their features. In order to meet the requirements of high precision, high efficiency, centralized processes, and fewer workpiece clamping times in CNC processing, CNC cutters have the features as below, compared with those used for ordinary machine tools. First, the cutting tools used for CNC milling machines are mostly multi-blade cutting tools with higher efficiency. Second, in order to enhance the efficiency and shorten the assistance time, the cutting tools should be serialized and standardized to ensure easy size adjustment of the tools. They feature the shorter alternation and adjustment time. the good interchangeability of cutting tools and blades, as well as the high precision and stable precision. Third, to satisfy the high speed and high efficiency cutting quality. The cutting tools require good rigidity and red hardness. The red hardness, also named heat hardness, refers to the characteristic of a tool that can maintain a certain hardness when it reaches a certain high temperature during high-speed continuous cutting. With this characteristics, the cutters have reduced thermal deformation, and the stiffness attenuation is decreased as well, thus meeting the requirements of high-speed, efficient, and high-precision machining of CNC machine tools. Knowing the types and features, we also need to know how to choose the cutters. Next, let's analyze the choice of CNC cutters. In choosing cutters, the factors, such as the type of contour being machined, the material of the workpiece, the allowable cutting amount of the machine tool, rigidity, and the durability of the cutting tool should be considered. And then, make reasonable choices for tool types, materials, and parameters separately. When choosing the milling cutters, the type should be suitable for the shape and size of the workpiece. Face milling cutters should be selected for processing larger flat surfaces, while end mills should be selected for machining step surfaces and planar contours with smaller grooves. When processing spatial surfaces, mold cavities, or convex mold forming surfaces, mold milling cutters are often used. And when processing closed keyways, we are used to choosing a keyway milling cutter. Drum-shaped milling cutters should be selected for processing angled surfaces, and when processing various straight or curved grooves, angled surfaces, special holes, etc., forming milling cutters should be selected. Besides the selection of types, we also need to choose corresponding materials. Choice of materials of cutters. Generally, standard cutters should be given priority, especially the hard alloy reversible cutting tools. When necessary, various high-productivity composite cutting tools and other specialized cutting tools can be used. For machining the workpieces with high hardness, solid hard alloy, ceramic cutting tools, and coated cutting tools can be selected. Then, knowing the types and materials, it's also necessary to select and calculate reasonable cutting parameters based on machining accuracy, tool durability, and other factors. Common milling quantities used in CNC milling includes cutting speed, VC, feed rate, F, back cutting amount, AP, and side cutting amount, AE, etc. In terms of tool life, the method for selecting cutting parameters is to first choose the back cutting amount or side cutting amount, then to choose feed rate, and finally to choose the cutting speed. In sum, the programmers should choose the cutters according to the life and regulations of the instruction when ensuring the cutting amounts of each procedure. When choosing the cutting amount, we must guarantee that the cutter can process one workpiece. In rough machining, the back cutting amount, AP, and feed speed, F, should be as large as possible, and then choose the best velocity of cutting, VC. In precision machining, we need to choose a proper back engagement, AP, at first, then the slow feed rate, F, and finally the high velocity of cutting, VC. For the different cutters and the cutting parameters of different workpiece, we need to decide through experience and check the list for calculation, which we will talk in the following classes. In this class, we have learned the types, features, and choosing principles of the common CNC milling cutters. The knowledge has guaranteed our high speed, high efficiency, and high precision in the future. Reasonable selection of CNC cutters will achieve twice the result with half the effort in fully utilizing the performance of CNC machining equipment, ensuring machining quality comprehensively and improving efficiency. Well, this is the end of the class. Welcome to focus on our class of numerical control. See you next time.